Syria, and we are going to discuss it in detail with respect to whatever can be asked from a competitive examination perspective. Now, firstly, all of you must be aware of this fact that there was a very recent earthquake that took place in Turkey on the 20th of February. So this is happening over and over again. The questions that we will put up today and the questions that we will discuss today is A, what has happened in Turkey and Syria? Secondly, how does an earthquake actually happen? What is the science behind an earthquake? What is the meaning of tectonic plates and how do they move? And finally, let's talk a little bit about why people are talking about an earthquake which might happen in India. So we'll talk about all of that. Let's start off with the very first one. So this is what you can see on your screens. There are three earthquakes. So you have to understand whenever an earthquake happens, and we'll get down to the whys of it in a little while. But whenever an earthquake happens, there are always aftershocks. Sometimes these aftershocks are of less magnitude. Sometimes these aftershocks are of a lot of magnitude, right? So what you can see on your screen right now is the very first one that took place on the 6th of February, which was of 7.8 magnitude earthquake. So then there were a lot of aftershocks. In fact, there were around 41 aftershocks that took place in a span of 12 hours right after that. And one of which was of a huge magnitude. And we'll understand what is the meaning of magnitude and intensity and what is the difference. But right now, let's look at this. So there was another one which was of 7.5 magnitude on 6th of February. And the one that happened on the 20th of February, which was just right now, it took place and it had a magnitude of 6.3, right? So let's go on to the next one. So what are we even talking about? So first we'll talk about whatever is in the context, whatever is in news, and then we'll get down to the whys of it. So on the 6th of February, there was a 7.8 magnitude earthquake, which was 17.9 kilometers below the Earth's surface. Now, you have to understand, even if you do not realize what is the meaning of an earthquake and why that happens, that whenever an earthquake or any kind of release of an energy happens, the longer it travels, the less is the intensity, right? But here we have a very, very shallow earthquake. And a shallow earthquake basically means that it has a lot of energy and it can cause a lot of devastation. So in a span of 12 hours, which I've just spoken about, there were around 41 more aftershocks that were witnessed in this particular location, one of which was really huge. The magnitude was really big, and that was 7.5 magnitude. And this too was a very, very shallow earthquake, around 10 kilometers below the Earth's surface. And this is why we are reading about the earthquake on and off in our newspapers, and we are looking at the amount of devastation that has happened, right? Shaking of the tectonic plates. I'm so glad that Shivang is here. Great, we'll get on to that. In fact, Shivang, now that you've mentioned tectonic plates, you have to, at the very onset, let's just talk about earthquakes. Earthquakes are basically shaking of the Earth's surface, right? It could be natural or it could be man-made. Now, you would say, how is it man-made? Now, it's a very simple thing, Imagine that there is an atomic bomb, Hiroshima, Nagasaki ki baat agar kare, to uske karan bhi Earth ka surface hila tha. There was a shaking of the Earth's surface, but that's a man-made earthquake. Most of the earthquakes are mostly natural and they take place in the lithosphere. What is the lithosphere? That is up to 200 kilometers beneath the Earth's surface. But we'll get on to that later. Let's first understand this. I would also like to welcome Satyam sir, who is with me right now. And yes, sir, if you could just...
Can't hear you, Priyanka.
Yes. So what we are talking about is So there was a 7.5 magnitude. Now you're looking at this and you're looking at these concentric circles, right? And there is something called hypocenter and epicenter, and we'll get down to that. But these concentric circles basically are telling you where these waves are going and where is it originating on the Earth's surface. So the very first one was a 7.8 magnitude next to a province called Gaziantep. Very, very important from our examination perspective, right? So you have to learn this name up, Gaziantep province. The second one was next to the Ekinozu province. And I'm sure all of you must be wondering, ki, acha, we've heard that the name of Turkey has become Turkey, and we'll get down to that later. Of course, it has, and United Nations has approved of it. But right now, let's understand what's an earthquake, and then we'll get down to why the name has changed. Now, on the 20th of February, which was just right now, there was another earthquake of a 6.4 magnitude, about 10 kilometers below the Earth's surface. Again, a very, very shallow earthquake. A shallow earthquake means, again, more energy and more amount of devastation. So another thing that we need to learn is, where was the epicenter? Ma'am, what is epicenter? We'll get on to that in some time. But it was centered near the southern Turkish city of Antakya. So you can see it right here, right? So you saw Gaziantep, and in a little while ago, you also looked at another epicenter, but this one was right next to Antakya. It was so huge. I mean, the magnitude was so much that the tremors were felt in Syria, Egypt, as well as Lebanon. Fine. Now, the signs behind an earthquake. ये earthquake होता क्या है और ये क्यों होता है, इसको कैसे रोका जाएगा? How do we predict an earthquake? Firstly, it is one of the most common forms of natural disasters, but unfortunately, we are not able to predict it. अगर predict ही नहीं कर पा रहे हैं, तो फिर उत्तराखंड और न्यू दिल्ली के बारे में बात क्यों हो रही है? So we'll get on to that. We'll talk about the tectonic plates in just a little while. But the basic definition of an earthquake is that the earth is shaking. Now, why is the earth shaking? Let's understand that. So you can look at it over here. ये तो हमें समझ में आ गया. So क्या हो रहा है ना कि if you talk about the earth, ये बहुत सारे tectonic plates, बहुत सारे plates. Imagine a lot of landforms floating above a liquid surface. Why is it liquid? Because there's liquid magma, right? So जब भी ये बहुत सारे earth के surface या solids, they are floating on a liquid phase, they will come in contact with each other. Sometimes the contact will be really less, sometimes the contact की intensity will be a lot, right? And because of which, whenever two surfaces, they come in contact with each other, there's a form of friction. So for want of better words, let me give you an example of a biscuit. Imagine you're holding a biscuit in your hand and you're trying to break it. So imagine when you're trying to break it, it becomes very rigid and all of a sudden it breaks. And there is a little line over there that breaks. That line is known as the weak part of that biscuit, or in terms of the Earth's surface, that is the fault line. So a weak part of this entire thing, whenever two tectonic plates are, going and, they're sliding towards each other, there is a very weak part that might break, which is also known as the fault line. So what am I talking about? I'm talking about release of energy. ये बचपन से सुनते चले आ रहे हैं, energy is neither created nor destroyed. It goes from one form to another. So what is happening is that rocks along a fault line. What is this fault line? It is right here. So we are imagining a biscuit. That biscuit can be sort of visualized as the tectonic plates, which are all over, right? So whenever that happens, as the overlying rock strata presses them, the friction locks them together. However, the minute the energy is a lot, it breaks, and it breaks from the weak point. That weak point is known as a fault line. The minute that fault line happens, the surface right above it, the rocks move in opposite directions. And what did I say? That energy is neither created nor destroyed. Now that this friction happens, now that this release of energy happens, it will go all over, right? And whenever it goes all over, so it will go right, north, south, east, west, some of it will reach the Earth's surface. And the area, So now what have we spoken about? We've spoken about an area where this is breaking, where the energy is releasing. What is this called? What is this particular portion? This is the Earth's surface, right? This is the body of the Earth. This is the lithosphere. Where does it extend up to? Up to 200 kilometers. अब इसके अंदर जब ये इन दोनों के बीच में फ्रिक्शन हो गया और ये चीज टूट गई, तो इस जगह को हम क्या बोलेंगे? फोकस. Another very scientific term that is given to a focus is called hypocenter. Very simple. Now the distance between, now what is epicenter? ये epicenter क्या चीज होती है? अब मैंने बोला यहाँ पे release of energy होगी, हर दिशा में जा रही है. It is also going down, right? It is also coming up. Now this is my Earth's surface. The position which is closest to the focus or the hypocenter is called the epicenter, right? Now, this is what is the magnitude of this earthquake. Ab imagine that, somebody is punching you on the arm and you're wearing your summer clothes. The punch ka, magnitude remains the same. But if you start wearing winter clothes, I'm wearing a sweater and another sweater and another jacket, and the same guy hits me with the same magnitude, the intensity that I will feel will be a little lesser. So that is the difference between intensity and magnitude. The magnitude shall remain the same. What is the magnitude? The magnitude is basically talking about that little fault line because of which that breakage happened. And that release of energy took place. And the area on the Earth's surface, which is closest to that focus, is basically called the epicenter. Magnitude तो same रहेगा, intensity vary कर सकती है. और intensity क्यों vary करेगी? क्योंकि ये अलग दिशा में जा रही है. So 1 में थोड़ा ज़्यादा हो जाएगा, 2 में थोड़ा कम हो जाएगा, 3 में थोड़ा और कम हो जाएगा. Intensity that I feel of the earthquake is a little different, right? So focus, like I said, is the point inside the Earth's surface where the release of energy happens, right? Magnitude, I said, shall remain the same, and the intensity, however, will be different because it will depend upon how far away are you from the epicenter. Yes, so that is why we spoke about Gaziantep and different other provinces, which you have to keep in mind from your competitive examination perspective. Now, the next thing is, just a second. Yeah. Okay. Just a second. I'm so sorry. Yes, we are here. Now, seismicity, and so we are reading a lot about, there are seismic waves and there's a lot of seismicity in areas surrounding Turkey. So what is happening? So what did I just tell you? I said this entire Earth, we can divide it into different plates, and these plates are moving, and we've already spoken about it, why this is happening. Now let's talk about Turkey and why this has happened in Turkey. So you can look at this. There is this Arabian plate, there's the Anatolian plate, and the Eurasian plate. ये seismicity इतना ज़्यादा क्यों है टर्की के around? क्योंकि these plates are interacting with one another. And what exactly happened on the 6th of February is that this Arabian plate is pushing northward, because of which the Anatolian plate is pushing itself westward, and Anatolian plate is where Turkey lies. And I told you, whenever there is a movement, there has to be a weak point, there has to be a fault line. And where is this fault line? It is the North Anatolian fault line, right? Then there are many fault lines over here. So because of which this particular earthquake took place. So the Arabian plate is known to be pushing northwards, which results in a slight westward movement for the Anatolian plate where Turkey is situated. Now, so Arabian plate is inching into the north of the Europe. ये Arabian plate जो है ये ऊपर जा रही है, जिस वजह से ये चीज मूव कर रही है, और कहीं तो fault line आ गई जो मेरे को दिख रहा है यहाँ पे North Anatolian fault के कारण, right? And most of Turkey sits on the Anatolian plate. Very important. And there is not one fault, there are two faults. ये कैसे पता चल रहा है? क्योंकि ये एक बार नहीं हुआ earthquake. Turkey में. It has happened many times in the past. In fact, in 2020, it occurred 33,000 times. तो हमने तो नहीं पढ़ा न्यूज़पेपर में, क्योंकि बच्चे मैग्नीट्यूड ही इतना ज्यादा नहीं था, तो आपने नहीं पढ़ा, इतना डेवस्टेशन नहीं हुआ. In fact, this happens. This is a very common thing that is happening, right? So in this particular case, there are two major faults: the North Anatolian fault and the East Anatolian fault. And so now the geologists say that this has happened because of something called the strike slip. अब भाई ये स्ट्राइक स्लिप क्या हो गया? बड़ी सिंपल सी बात है, ये आप यहाँ पे देख लो. तो ये क्या हो गया? Rocks beneath the surface contain points of weakness. And when I say weakness, what are you going to think about? You're going to think about the fault line. So epicenter faces the maximum destruction, right? Most definitely, absolutely, because that is where the energy is. That is the closest point to the focus, right? Shivang, absolutely correct. So the rocks beneath the surface contains point of weakness, after which what is happening? These are moving in opposite directions, and then that is what is happening. Abhi waves की बात नहीं की है, अभी पता ही नहीं है ये कौन सा टाइप का वेव है, अभी बॉडी में क्या चल रहा है, सरफेस में क्या चल रहा है, वो कर रहे हैं अभी एक एक करके, पॉइंट बाय पॉइंट, स्टेप बाय स्टेप हम लोग इस चीज की बात कर रहे हैं. सो दैट इज व्हाट इज अ strike slip, which is what the geologists are saying. So why are they saying these things? And they are putting words like it might happen because of this, इसके वजह से हो सकता है, उत्तराखंड में एक earthquake आ सकता है, because it is unpredictable. Why is it unpredictable? Because we do not know when will that fault occur and when will that release of energy happen. We might have an understanding as to where the fault lines are. And why do we know that about the interior of the earth? Because some of the other earthquake must have happened in the past, because of which these geologists have gone and they've studied the earth's body and they've said, yeah, it might happen here, right? Because of which we can say there is a probability of an earthquake in the future, but will it happen? Will it not happen? Can we say it 100%? We can't. लेकिन जैसी वो फोकस आता है, जैसी वो हाइपो सेंटर बनता है, तो हम उसको कैलकुलेट करना शुरू कर सकते हैं. वो कैसे करेंगे वो थोड़ी देर में देखेंगे, ठीक है? Now, reasons for the devastating nature of the earthquake. I've spoken about the many fault lines, right? Secondly, we can also talk about the shallow nature of this earthquake. Right, and it is said that the fault system runs along nearly 190 kilometers. Imagine, this is such a long stretch of a weak line that can break at any moment, because of which this earthquake can take place. Fine. And the second earthquake, which was of 7.5 magnitude, occurred further to the north on a different but an adjacent fault called the Surgo fault. So this is also something that we can keep in mind for this. Now let's go ahead. How do we measure this?
Priyanka, I just want to add here that because of this fault line here, 190 kilometers fault line, the tremors were felt as far as Istanbul and even Cairo, Egypt.
Absolutely, sir. Absolutely correct. So, looking at the magnitude, the intensity can vary, but when the magnitude is so much, as sir has just said, the intensity can also be a lot, and it can be felt at far off places, right? Now, how do we measure an earthquake? Of course, till the time the fault does not occur, we do not know it for a fact that an earthquake is going to take place. But that doesn't stop us from measuring it. And the object that measures it, or the system that measures it, is called the seismograph. So you can see it over here. So ये आप देख रहे हैं कि ये चीज, ये जो पेंसिल है, ये आराम से ये concentric circles लगा रही है, but the minute a wave comes and it goes haywire, it will start calculating it, right? ये कौन सी wave है, ये अभी हम देख रहे हैं, थोड़ी देर में देख रहे हैं. Apart from that, you can keep this in mind that the earthquake magnitude has also like a lot of categories. So of course, like a 3.3 to 3.9 Richter scale will be considered to be a very, very minor earthquake. Something which is more than 8 will be great, will be very, very devastating. And this is where we are talking about this as well as this. ठीक है? अब ये कौन सी waves है? We are just talking about it. So Of course, so seismic waves, ये होती क्या है? So something happens within the body of the earth and then something happens on the surface of the earth. So hence, these waves are categorized into two. One is known as the body wave and the second is known as the surface wave. बड़ी बड़ी simple सी चीज है, आपकी NCERT में जिन्होंने geography की है उनको पता भी होगा, right? So अब body waves की अगर हम बात करें तो ये दोनों की बात करें, P wave is called primary wave, S wave is called secondary wave. Simple as that. Primary wave क्यों? ये सबसे पहले पहुंच गई. Secondary wave क्यों? बाद में पहुंच गई. अच्छा, इन दोनों में difference क्या है? I'm going to take a very simple example that most of the geologists take. So imagine you're standing in a very straight line, right? You're trying to take tickets. Movie theater में tickets आप लोग ले रहे हो और मेरे को बहुत जल्दी है, मैंने सामने वाले को ऐसे पुश किया और कोई इधर उधर आड़ा टेढ़ा नहीं गया, सारे के सारे they are going and cramming into each other. So that is what is the P wave. You can see it here. It is within the Earth's surface. The S wave is when people start going aada teda. Of course, this is oscillation, but ये S wave है, ये this is also within the Earth's surface. जब ये दोनों की दोनों आती है एंड टकराती है अर्थ के सरफेस से, तो बॉडी ऑफ द अर्थ पे जो वेव होता है, दैट इज कॉल्ड द सरफेस वेव, ऑल्सो कॉल्ड द लव वेव, राइट? बिकॉज ऑफ द नेम ऑफ द जियोलॉजिस्ट हु केम अप विद द सरफेस वेव्स एंड टोल्ड अस व्हाट आर सरफेस वेव्स. सो इफ यू आर आस्क्ड व्हाट आर लव वेव्स, दे आर ऑल्सो सरफेस वेव्स. अब सबसे ज्यादा डेविस्टेटिंग जितने भी बच्चे यहाँ पे बैठे हैं, कौन सा होगा? लॉजिक लगाओ. एक अर्थ के बॉडी में हो रहा है, एक अर्थ के सरफेस पे हो रहा है. सबसे ज्यादा डेविस्टेटिंग जिसके कारण घर टूट रहे हैं, बिल्डिंग्स आर कोलैप्सिंग, पीपल आर डाइंग, which one will be that? Will it be the surface wave or will it be the body wave? Quickly, tukka maro, hardly matters. Just think about it logically. You're standing on the surface of the earth and there is something happening beneath the earth, in the earth's body. Will that make it more devastating? Or more devastating kya hoga? Surface wave ki body wave? Come on, write it down. I'm going to wait for you to write it down. Meanwhile, this is how it is recorded in the seismograph. Don't worry बेटा, सही होगा, गलत होगा. तुम बैठे ही इसलिए हो क्योंकि तुमको आता नहीं है. चलो, Shivang, take the lead. Come on, tell me, which will be more devastating? That which is happening within the earth's within the body of the earth, or that which is happening at the earth's surface? Surface is absolutely correct. तो wait क्यों किया? Well done. All of you are correct. Adrika, Shivang, Ministry, Shreyas, very well done. यही बात है. ठीक है. अब P wave और S wave की बात करें तो ये दोनों के दोनों क्या हो रहे हैं? अर्थ की बॉडी के अंदर हो रहे हैं. एक प्राइमरी है, एक सेकेंडरी है. The primary wave is moving faster and it is the first to arrive at the surface. Why? Because it is going to travel through gas, liquid, solid matter. बेटा gas में air में आएगा तो क्या ही earthquake होएगा? Liquid and solid makes sense here, but I'm just talking about the property of the wave. It's very, very similar to that of sound wave, right? If you talk about S waves, not surface waves, which one are we talking about? Secondary waves. Now, in this particular case, well done, all of you are correct. In this particular case, this is only traveling through the solid material. इतना ही समझना है. ये solid, liquid, gas तीनों में से जा रहा है. ये सिर्फ और सिर्फ किस में से जा रहा है? सिर्फ solid में से जा रहा है. Now, earthquake wave, surface wave तो आप लोगों ने मेरे को already बता दिया. Before I had to tell you, you told me and you're absolutely 100% correct. But बच्चे, this will be the last to be reported on the seismograph क्योंकि ये से बिल्कुल end में आ रहा है ना. So that is why the devastation is so much, because we are not able to analyze it very properly, right? They cause the displacement of the rocks. You've already told me, so we can go ahead. Now let's look at another concept. Now, before we look at this, you have to think about the birthday parties that you guys go for. So I don't know if the birthday parties and the games have changed, but back in the day when I was a child, when we used to go for birthday parties, we used to have this game wherein we used to keep a bucket, we used to fill it up with water, we used to keep like a little katori at the end of the bucket, and we used to try to put a coin inside that katori. And whenever I used to try to do that, I used to try to throw this coin and I used to look at the कटोरी, it used to not go inside that, it used to go astray, कहीं और ही चला जाता है. इस कॉन्सेप्ट को साइंस में क्या बोलते हैं, फटाफट से बताओ. रिफ्लेक्शन बोलते हैं कि रिफ्रैक्शन बोलते हैं, कि मतलब पानी में जब मैंने वो चीज डाली तो कटोरी तो मेरे को दिख रही है ना, तो वो उधर ही जानी चाहिए ना, पर वो थोड़ी आड़ी टेढ़ी चली जाती है. व्हाट इज दिस कॉल्ड? इज दिस रिफ्लेक्शन और इज दिस रिफ्रैक्शन? Come on, everyone. Shivang, Adrika, Minishti, Shreyas, Riya, Harshit. Refraction or reflection? I don't know your birthday parties now. Huh? They might be very, very fancy. In my day, they weren't fancy at all. Well done. Well done. So what did I say? कि ये P wave है, ये आपकी S wave है, ये प्राइमरी है, ये सेकेंडरी है. प्राइमरी किस किस में जा रही है? सॉलिड, लिक्विड, गैस. सेकेंडरी किस में जा रही है? सिर्फ सॉलिड में जा रही है. और मैंने क्या बोला कि आपके अर्थ के सरफेस में कुछ एरिया ऐसा है जो कि लिक्विड भी है. Now, whenever this is going, तो ये सीधा नहीं जा रहा है, ये थोड़ा टेढ़ा हो रहा है. वो टेढ़े को हमने क्या बोल दिया? आप सबने बता दिया, रिफ्रैक्शन. आई एम लविंग इट, ऑल ऑफ यू. आई होप यू प्लेड दैट गेम, अदरवाइज आई साउंड एंशिएंट. रिगार्डलेस, वी हैव अंडरस्टूड इट. तो यार अगर ये टेढ़ा इधर से हो रहा है ना, तो इस पर्टिकुलर एरिया में अगर कोई सिस्मोग्राफ पड़ा है तो इट विल नॉट बी एबल टू मेजर द अर्थक्वेक, बिकॉज ये तो शैडो जोन है. यहाँ पे तो वेव आई ही नहीं. क्यों नहीं आई? आपने बताया, बिकॉज ऑफ रिफ्रैक्शन. अच्छा मैम, लिक्विड से फिर से जब वो सॉलिड में जाएगा फिर से रिफ्रैक्ट करेगा, तो फिर से इसको थोड़ा टेढ़ा कर दिया. सो हेंस इफ आई कीप अ सिस्मोग्राफ हियर इट विल रिकॉर्ड इट. इफ आई कीप अ सिस्मोग्राफ ओवर हियर इट विल नॉट रिकॉर्ड इट. व्हाट डू I understand and what do I need to learn from CLAT? The area where a seismograph cannot measure the waves is called a shadow zone. Simple as that. और कुछ नहीं आपसे पूछेंगे. But I'm glad that you guys have understood it. Right? Haven't played it yet, but imagined it through the way you told. I'm glad. It's a good game. I don't know what you guys do on birthdays these days. That will be a topic for another day, but I'd really, really like to know. Yeah? So, yes, sir. I'm sorry, I thought you were... okay, so the next one is the earthquake in Turkey and Syria, areas exposed to shaking. ठीक है, अब क्या कर दिया हमने, डिफरेंट इधर दिखा दिए जहां पे एपिसेंटर है. शिवांग, आपने जो क्वेश्चन पूछा था कि जहां पे एपिसेंटर होगा वहां पे सबसे ज्यादा इम्पैक्ट पड़ेगा, वहां पे सबसे ज्यादा मैग्नीट्यूड नहीं इंटेंसिटी होगा. जितना जितना हम लोग एपिसेंटर से दूर चलते जाएंगे उतना जितना, वेल डन, ये दूर ही चले गए हम, तो जितना जितना दूर चलते जाएंगे उतना उतना इंटेंसिटी रिड्यूस होता जाएगा. इट्स एज सिंपल एज दैट, राइट? एंड शैडो जोन जो होगा वहां पे इंटेंसिटी कुछ आएगा ही नहीं, बिकॉज इट्स अ शैडो जोन. इट्स एज सिंपल, राइट? नाउ let's talk about the devastation that has happened because of this particular earthquake. More than 47,000 lives have been claimed by the earthquake so far. And that's a lot, right? And it is increasing. Every single day that we read the paper, there is someone or the other. And now comes the concept of globalization. Now, of course, there were days during the COVID-19 pandemic when we were saying a lot of things which were, we were saying things like, oh, why is there globalization? Because ek jagah se virus dusri jagah pe chala gaya. But you also have to understand that when such a devastation happens in a country which is Turkey, also called Turkey these days, a country that has very vehemently opposed India in many international forums, right? At a time like this, when such a huge catastrophe happens, we send our relief group to that particular country. And why would we do that? Because we are, in fact, a part of globalization and we should take care of each other. And that is a big and a huge and a very commendable step that has been taken by the government of India. Now, so UN and other countries are still on the rescue and relief missions as of now. I'm so sorry I'm doing this, right? I'm a little technologically retarded, right? So this is the strongest earthquake that in the region in the past 100 years, right? Properties worth billions of dollars have been ravaged because of the earthquake. There are mosques, there are ancient monuments that have been completely destroyed. So, of course, the world has to come together. Vasudev Kutumbakam, absolutely right, right? So, we have to come together and we have to make sure that we build this country from ground zero, because of the fact that, of course, we are not really an inward looking economy. We are here to embrace everyone. And this also shows the power that India has, right? Okay. So Operation Dost. Now, Operation Dost, this somebody had already written it in the comments. So I'm so glad that you guys are aware of it. It's a humanitarian step. It's okay if you're a country who opposes us in an international organization. It's okay if you support certain countries with whom we don't support. But at the end of the day, this is one planet, right? And one family. So hence we are going to send our people to this particular area to take care of the people who have been destroyed because of this particular earthquake, right? So this has been launched by the Indian government as a humanitarian aid to the quake hit Turkey. Now, another thing which is very, very important here is that we have also sent our women personnel, right? Of course, whenever there is a disaster, it becomes a little imperative to send certain genders which have been termed as weak in the past, because it's a very simple thing. If a natural disaster happens, and I have to go and ask for help from somebody who has come from a foreign country. Personally, I would rather go to a woman than a man. I might feel safer, in imagining the fact that my house and my property is all gone, and, I've suffered such a huge loss. I might be able to go and talk to a woman rather than a man. This is such a beautiful step, right? This is also women empowerment. And so this is what India has done. It has sent search and rescue teams, mainly 3 teams of the National Disaster Response Force, NDRF. And we've, made a field hospital and materials and medicines and equipments to Turkey as well as Syria. So we've also sent 4-wheeled vehicles and trucks, apart from canines, our dogs who've found a lot of people who've been, under the rumbles, and which is really, really good. Okay. So iske alawa, we've also airlifted a lot of people. In addition, we've sent a lot of people and equipments so as to be able to take care of this particular country during this time. Okay. Correct. Gaziantep, Kalisi, and Yeni Mosque. That's right. Okay. Now the next one is some major earthquakes in India. Now we can talk about certain major earthquakes in India, because you see, whatever happens now, if we talk about the previous CLAT examination, which happened on the 18th of December, if whatever is in the current, the static becomes important, correct? And so hence, if there is a huge disaster that has taken place, we should, as aspirants, know about the kind of disasters that have taken place in our country previously. Fine. So some of the major earthquakes, we can discuss them. One of them was Gujarat. So hence, in this particular case, when did it occur? So what are we going to, that's all that we need to know. Kab hua? Epicenter kahan tha? Earth ke surface pe. Hypocenter kahan tha? Body of the earth pe. Probable fault. Arey, what is probable fault? Itna saal ho gaya, aapko pata hi nahi hai ki fault kis wajah se hua. You see, it is not that simple. It could be many, many different factors. Imagine going to the earth's surface. Okay, now imagine you're drilling into the earth's surface. Will it get colder? Will it get hotter when you get inside? Tell me. आप ड्रिल कर रहे हो, आप अर्थ के सरफेस के अंदर जा रहे हो, माइनिंग कर रहे हो, चलो आप जैसे जैसे अंदर जा रहे हो, वो सरफेस, will it get hotter or will it get colder? I'm waiting for your answer. It'll get hotter, right? So it is not possible to keep digging in, no? So how do we come to know about the interior of the Earth's surface? Many factors, one of which are earthquakes. ठीक है, तो ये probable fault है, magnitude कितना है और कितने लोगों की जाने गई, ठीक है? तो इसमें हम लोग earthquake के बारे में बात कर रहे हैं. And when did it occur? It occurred on the 26th of January 2001. This is the 51st Republic Day. They might ask you the date. They might ask you kaun sa wala Republic Day hai. Hotter because of molten state. Absolutely 100% correct, right? So this was the 51st Republic Day, and it lasted for about 2 minutes. Epicenter. 1 second. Epicenter. So this is near the earthquake that took place in Gujarat. The hypocenter was 16 kilometers deep. This is also relatively shallow in nature, and hence the devastation was a lot, right? तुम लोग शायद पैदा भी नहीं हुए होगे, शायद हुए होगे. 2001 की बात कर नहीं हुए होगे, right? So probable fault is the Kutch Myland fault. You can see it right here, है ना? ये गुजरात की बात कर रहे हैं, Great Run of Kutch की बात कर रहे हैं, यहाँ पे आपका पाकिस्तान हो गया, इस एरिया की बात हो रही है. Right here. So this is the Kutch mainland fault. And now we've understood what is fault. It is that weak point where everything goes bad and there's a release of energy, there's a focus, and then there is epicenter. We've all understood that. Magnitude was 7.9 on the Richter scale, and it claimed more than 20,000 lives. There are just 3 of them that we are going to talk about, right? The next one is Maharashtra. Now, it'll be interesting for you that the peninsular India is considered to be relatively stable. वहां पे कहते हैं कि natural earthquake नहीं आता है, क्योंकि आया ही नहीं है बहुत देर से. क्या अभी आ सकता है because I said that it's very unpredictable, but it is said by the geological survey that the peninsular India is relatively stable than the Himalayan region, because Himalayas बने ही क्यों है बेटा? Because of the tectonic plates. अब मेरी बात सुनो, tectonic plates ऐसे टूट के बिखर नहीं जाती जैसे बिस्किट बिखरता है, वो फोल्ड होके ऊपर हो जाती है, तभी तो हिमालय बना. तो हिमालय में बहुत सिस्मिसिटी है, इसीलिए बोल रहे हैं कि शायद पता नहीं हो जाएगा, अगर होगा तो बहुत ही बड़ा रिक्टर स्केल पे हो जाएगा. This is what we are predicting. But when you talk about the peninsular India, they say natural earthquakes may not happen, but what will happen? Man-made. So this is one example. Again, a probability quotient, right? So they've said that this happened in 1993 in Maharashtra, and the magnitude was 6.4 on the Richter scale. And the epicenter was the Kilari village in the Latur district. Hypocenter was 10 kilometers deep, again very shallow. But this is probably because of the reservoir that was being constructed. That is also another reason why the earth shakes. There's a huge reservoir that you're making, right? In case there's a little bit of an issue, the earth will shake. This is what is the probable cause of Maharashtra. But that is what it is said. And in the peninsular region, this is one of the largest earthquakes to have occurred. And lastly, Uttarakhand, very, very important. The year that this happened, Uttarakhand was a part of Uttar Pradesh. ठीक है, तो कहीं पे उत्तर प्रदेश भी लिखने को मिलेगा. That is completely fine. Yes, and otherwise, Uttarakhand was carved out of Uttar Pradesh in the year 2000. Bihar में से झारखंड, है ना? मध्य प्रदेश में से छत्तीसगढ़, and उत्तर प्रदेश में से Uttarakhand. So the epicenter was 10.5 kilometers, hypocenter was 12 kilometers deep, relatively shallow, 6.6 on the Richter scale, took a lot of lives. And the Himalayan range was the reason why this happened. So this is what we are going to talk about, and then we will discuss certain trivia with respect to Turkey, which becomes very, very important from your examination perspective. So if you look at the map of India, this is the current map of India. We've divided India into many, many zones. How have we divided it? We've divided it because of the fact that we've seen a lot of earthquakes that have happened in the past, and we have a little bit of an idea as to the interior of the earth. So hence, if you look at this very, very dark portion. This is considered to be extremely severe. इधर seismic activity बहुत ज़्यादा है, अगर आएगा तो बहुत ही severe earthquake आ जाएगा. फिर उसके बाद थोड़ा कम है, जैसे कि ये लद्दाख में, जम्मू एंड कश्मीर में थोड़ा सा पॉइंट है. पंजाब में थोड़ा सा सेकेंड लेवल का सिवियरिटी है, थोड़ा सा कम भी है. चंडीगढ़ थोड़ा सा इधर को है. नाइस, राइट. एंड ऐसे ऐसे करके थोड़ा सा इसकी सिवियरिटी कम 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 होती जाती है. ओके, so now we will go ahead and we will talk about the trivia with respect to Turkey. Again, extremely important. Earthquake आ गया तो आपको location वगैरह पूछा जा सकता है. So let's get on with that. Yes. Apart from it, hazard mitigation is आप seismologically monitoring centers बना दो, आप कोई vulnerable areas map कर दो. अच्छा, मैं I was thinking when I was reading about it, I said यार घर shadow zone में होना चाहिए, पर shadow zone तो fault line की वजह से होता है, and it is a very relative thing. आज वो shadow zone है, कल वो नहीं है, क्या पता हम लोगों को. So that is something that we can't do. But Japan is also very seismically, it is in a zone which is very seismically active. पर वहाँ पे इतना ज़्यादा damage नहीं हो रहा. क्यों नहीं हो रहा? Because of the fact that they have constructed their buildings in that manner. Is that okay? Right? And robust implementation of the rules of the civic authority. Now, let's start off with the associated trivia, exceptionally important for your exams. Sir.
Okay. Now, before we do this, I'll just, do a basic recap of the points that Priyanka has just mentioned. First is that the date of the earthquake, 6th of February, the province was Gaziantep. The area was called Nurdagi, and which is about 23 kilometers off the epicenter. She mentioned about the hypocenter. Hypo was just 18 kilometers off. Now, the impact of this earthquake was felt across because the fault line was about 190 kilometers, and this was primarily the eastern Anatolian fault, because of which is about 190 kilometers. Now, before we get into the trivia, I would like to ask you a few things just about Turkey. First is, what are the neighboring countries? What are the countries that share border with Turkey? Can you just tell me a few? What are the countries that share border with Turkey? Can I have some answers here, please? What are the countries that share border with Turkey? Okay. No, Ministry, Lebanon doesn't share boundary. Lebanon is somewhere here. It doesn't share boundary with Turkey. And by the way, what is the capital of Lebanon? Armenia, Greece, right? Syria, Georgia. All right. All right. So, so we have Greece here. Greece is somewhere here, right? This is Greece. And above this is Bulgaria. The capital of Greece is Athens. Bulgaria is Sofia. And then you have the Black Sea. The best way to, remember. So this point is very important. This is called the Bosphorus Strait, right? And Istanbul is the largest city in Turkey. And the city is, on both sides of the Bosphorus Strait, right? So the European part is somewhere here. And this is the European part. And this is the Asian part, right? And this is the Sea of Marmara. So this is one of the choke points, which is important to know. And this choke point, this strait or Bosphorus Strait, which is about 23 kilometers long and about 3.8 to 4 kilometers wide, it's a narrow shipping lane, right? And it gives you access to Black Sea. Therefore, Turkey plays a very crucial role, and therefore it was being a Muslim-dominated country, it was became part of NATO in 1951. Now, this is the Sea of Marmara, and this is the Dandelion Strait, which gets you into the Aegean Sea, which enters into the Mediterranean Sea. So the way to remember this is BAM, B-A-M. Okay, Black Sea, Aegean Sea, and the Mediterranean Sea. So this is that bit. Okay, so now this is one fault line. And if you see here, you can check the map yourself. On the northeastern part, you will have Georgia. So it doesn't share any boundary with Russia. Earlier, yes, because Georgia was part of USSR. The capital of Georgia is Tbilisi. Below that is Armenia, which is somewhere here. The capital of Armenia is Yerevan. And it shares a very small boundary with this country called Azerbaijan. You must have heard of this war last year between Armenia and Azerbaijan, right? So the capital of Azerbaijan is Baku. And then if you come below, this becomes Iran, and then is Iraq, and then is Syria, right? So these are the countries that share border with Turkey. So Iran, Tehran, Iraq is Baghdad, and Syria is Damascus. So Beirut doesn't, Bulgaria, which is right here, and the capital is Sofia. So these are the countries. Now there is a small island here, which is called Cyprus country. And so although not a neighbor, but yeah, Cyprus is also one of the countries which is very close to Turkey. The capital of Cyprus is Nicosia. And if you go back to history, I don't know if you've seen this movie Troy, very popular movie. So the Greeks actually entered the city of Troy, which is somewhere here, and there was this famous Trojan War, right, where Hector loses to Achilles, and so you must watch that movie. It's a great movie to watch. So the Spartans, they attacked the city of Troy, right? So Troy is part of Turkey. The capital of Turkey is in fact Ankara, and Istanbul is the largest city, right? What else? Yeah. So more about tidbits. How did Turkey actually was part of this Byzantine Empire for almost 1,000 years, from 1453 onwards. The present day Istanbul, became the capital, and this was till 1923, 29th of October, when it was they got the independence from the Ottoman Empire, and Mustafa Kemal Pasha became the leader of the first president of Turkey, right? And he got a lot of radical changes in Turkey, and more Europeization, and the culture became more Western. So I'll just take you across a few things that I feel that you should know. So please, remember about the Black Sea, the choke point, which is the called the Bosphorus Strait, the Sea of Marmara, the Dandelion Strait, and gets into the Aegean Sea, and that gets you to the Mediterranean Sea. So this is important because it will come. Yeah, so we have mentioned it here, so you would know. Sofia is here, which is capital of Bulgaria, right? Okay, now, so I mentioned about Mustafa Kemal Pasha. He was the first, he was the father of the present day Turkey. He got a lot of reforms, right? They became republic in 1923. The exact date is 29th October. And yeah, a lot of, so now, in fact, if you see, Turkey has a lot of Islamization that is happening of late. 2014, the president Recep Erdogan, he's tried to Islamize a lot of things there, and you must have heard about this mosque there, which is called Hagia Sophia, and it was earlier during the Byzantine rule, during the Ottoman rule, it was a mosque. And when Kemal Pasha, became the president in 1923, he converted that into a museum. And in 1919, it again became a mosque now, right? So Hagia Sophia was quite, in news last year. So Turkey is a gateway to Europe and it has most of its part is in Asia. A small part is in Europe. Okay. And I've already mentioned about the water bodies here. Istanbul is the largest city and very prone to earthquakes because of the because 95% of the area is in the Anatolian region. It is part of the northern fault line and the eastern Anatolian fault line, right? So which is also mentioned here. What else? Yeah, so I can just we can do a little bit of quizzing now, and let me ask you a few questions. So what strait lies between the Black Sea and the Sea of Marmara? Can I get some answers here? What strait lies between the Black Sea and the Sea of Marmara? What is it called? Yeah, Helen of Troy. The war was for her. Guys, I just did this. Which strait lies between the Black Sea and the Sea of Marmara? It's called what? Bosphorus Strait. It's called Bosphorus Strait, right? It's one of the most important. It's the most important shipping lane, and it gives you access to the Black Sea. Yeah, Bosphorus Strait. Correct. Who was the founding father of the Republic of Turkey? Second question. Who is the founding father of the modern Turkey, Republic of Turkey? Or may I say, father of the nation? Who was the one who defeated the Ottoman Empire? Absolutely. Mustafa Kemal Pasha, also known as Ataturk, and he was the one who defeated the army, he led the army and they defeated the Ottoman Empire. So from 29th October 1923, the Republic of Turkey was formed, right? The third one. When did Turkey join NATO? What was the year? Turkey joined NATO. Which year? Yeah, absolutely. What is NATO? North Atlantic Treaty Organization. And Turkey joined NATO in year 1952. Absolutely. And they play a very strategic role because Turkey, through the Bosphorus Strait, gets access to the Black Sea, right? And you need to take permission from the Turkish government to enter into the Black Sea. Therefore, they are sitting on a very important location, strategically very, very important. What is the name of the humanitarian aid program extended by India to the earthquake? The capital of Turkey, you all know. What is the capital of Turkey? What is the capital of Turkey? Ankara. Capital of Turkey is Ankara. And what is the humanitarian aid? The program extended by India to earthquake? Yes, Operation Dost. So you should know about Operation Dost. And what is the team that we sent? What is that team called? The team that we sent for the rescue operation? the team is called NDRF, right? NDRF, National Disaster Response Force, right? NDRF, right? So you should know about Operation Dost and you should know about NDRF. There is also a SDRF, which is a state disaster response force, but NDRF is what is most crucial here. So NDRF, SDRF, and the Indian Army, right? So if they ask you this question, the answer will be NDRF. So Turkey is located on which tectonic plate? What is the answer to this? So we just did that. 95% of Turkey is based on this particular plate. Priyanka mentioned to you about the north and the eastern part. The earthquake took place on the eastern part. But what is the plate called? Absolutely. Very good, Ministry. Anatolian plate, right? This is where the earthquake took place, the eastern Anatolian plate, which is a 190 kilometers fault line, and therefore the effect was felt across, even in Western Europe and in northern parts of Africa and in the Middle East till Israel, right? Which earthquake has been most devastating in the last 100 years? What about this? The most devastating earthquake. The most devastating earthquake. Okay, it was in Chile in the year 1960, and it was 9.5 on the Richter scale, right? So the most devastating earthquake was in Chile in the year 1960, right? It was 9.5 on the Richter scale, right? Okay, when did the Ottomans take over Constantinople? Yeah, not limited to Turkey. So this is the present day Istanbul. Which year was this? The Ottomans took it over from the Byzantine. This was 1453. 1453, and they've ruled for almost 500 years. Right? So that's about it. That's a quiz that we did. Priyanka, are you there?
So,
yeah, so I hope this topic is clear to you guys now. And just 7-8 pointers as far as this topic goes. One, we should know about Operation Dost. Second, we should know about NDRF. Third, Turkey is part of the Anatolian plate. The fourth, the epicenter of the earthquake was Gaziantep, right? And so you should know that, which is the province is called Gaziantep. And fifth, you should know the country sharing border with Turkey. Sixth, you should know about the water bodies surrounding Turkey, which is Black Sea, Sea of Marmara, Bosphorus Strait, and the Strait of Daedalus, and Aegean Sea, and then the Mediterranean Sea. The important earthquakes that have taken place in India. So Priyanka has already mentioned about that. The one in Gujarat, the one in Maharashtra, and Uttarakhand, right? Priyanka, that's about it.
Yes, sir.
Anything else?
No, I think we've analyzed the topic well.
Yes, and the last thing was which wave is most destructive, which is the surface wave, right? As compared to the P and the S wave.
Absolutely.
Yeah, so I think this topic is done. So I think as far as this earthquake in Turkey is concerned, from a CLAT perspective, you should know these 10, 12 things.
Absolutely. Right? And the seismograph, which has already been explained.
Yeah. All right. So you can conclude, Priyanka. Thank you.
Thank you, sir. Thank you so much. And thank you, everyone. I think it has been very nicely explained by sir. And well, I would... So you should know all of these topics. And I think now that if, whenever there is a question with respect to an earthquake, you would know what's a seismic wave. You would know the difference between body and surface waves. You would know a seismograph. You would know a hypocenter and a focus and an epicenter. You would know the difference between a magnitude and intensity of an earthquake. You would know the importance of an epicenter. And of course, the geographical location is extremely important because you see, whenever you see these competitive examinations, the questions that you think are going to be asked, it's a little different from that. So I'm glad that you now know the associated trivia with respect to Turkey, because for all you know, you would be asked about, let's say, what is the name of the strait that sir has just spoken about. And I'm sure you've understood it so well. Kindly make a note of all of this. And thank you so much from my side. And thank you so much, sir, for this wonderful session.
I'm looking forward to more.
Yes, sir. Yes, sir. Definitely. Thank you. All right. Bye-bye. Thank you, guys. All the best.